So, hello and welcome to the first Ecash conference. 40 years after we actually invented this tech, we finally get together and talk about it in depth. And it's quite extraordinary how much has advanced in these last 40 years in Ecash technology. And of course, you all know Cashew and Fedimint as prime examples of the of the initial use case of Ecash, and that was as money warehouse receipt. Right? You give someone your bar of gold or your fiat cash or your Bitcoin, and he instead gives you the electronic signature back that gives you the access right back to the money whenever you want it. And the cool thing is these access right tokens can be transferred to other people anonymously and extremely fast and cheap. So that means that, well, since the very beginning, Ecash was the ideal technology for digital payments, and that's what it was envisioned initially, and that's what we mainly see it implemented today. But that's not the only use case of Ecash. There's actually a lot of great things that you can do on top of this naive money warehousing receipt. And so let's talk a bit about a story of maybe an unknown Ecash project that nevertheless was successfully deployed in 2018, and that is Wasabi Wallet. It uses Ecash in a novel way, not as money warehouse receipts, but as API access right tokens. And so let's walk a bit through the reasoning of why this is a compelling use case. So what the core idea of Wasabi Wallet was the idea of a coin join, a collaborative Bitcoin transaction, which means we craft a transaction meant to go onto the Bitcoin blockchain, but it does not only have one input and two outputs of one user. Instead, hundreds of users get together and each register their inputs and their outputs so that we have a collaborative transactions, hundreds of inputs, hundreds of outputs. And that gives a meaningful privacy improvement to blockchain transactions. The big problem with this is if 100 users want to sign the same transaction, that's a consensus problem. Right? How do we agree not just which inputs and which outputs, but which ordering of those inputs and outputs do we have? Because that we all need to have the exact same transaction to be signed. And there are, of course, advanced decentralized consensus mechanisms. Fedimint, for example, uses one of them. But that's quite difficult and complex to pull off. So since forever, centralized architecture, centralized computer systems were used to establish a consensus among users simply by one server, one computer, proposing to the other users that this is the transaction that we're going to sign. And so the server collects the inputs and the outputs and the signatures of each user and helps this group of unknown people to collaborate and find consensus on the transaction to be signed. Now, of course, the problem here is if we want to achieve privacy, then we cannot have a ID system tied to an account, for example. Because if the user creates an account and then inside one account, he registers his input and he registers his output, the server can easily check that he's not taking more money out of the system that he's putting in, right? That the user's input are larger than the outputs, basically. That is a rule that the coordinator has to check so that everyone is happy in the end and nobody is creating money out of thin air. Right? Because ultimately we need to have a Bitcoin transaction where all of the inputs are more valuable than all of the outputs. And so if we would have a system where anyone can anonymously register outputs, then he would come and say, I want 1,000 Bitcoin to this address, thank you very much. But he doesn't provide any inputs in this transaction that spend these 1,000 Bitcoin. So ultimately, the inputs are much smaller than the outputs and the transaction is invalid. And if we would solve this problem with an account model that the mint verifies that these inputs and these outputs belong to the same server, then we don't have true anonymity. Right? The outside world might not know that these inputs and outputs belong to the same person, but the server knows it. And once this information is revealed from the user to a service provider, this information can be gossiped, right? Either voluntarily or get hacked or compromised in other ways. So it is essential that we find a way to limit registering of outputs to only those users who also registered inputs of at least the same value or more. Right? But we need to do this in an anonymous fashion so that nobody can link the first API call, input registration, to the same user's second API call, output registration. Right? And the way that we can solve this is rather easy with Ecash. Right? When a user successfully presents his input, the mint responds with a signature over some ciphertext, a blinded message that the client received, and the client can unblind this signed ciphertext and now has a valid Ecash token, right? A clear text nonce signed by the private key of the mint. And the mint chooses the value of the token basically. Then this is yet another interesting use case that on the Bitcoin on-chain transaction graph itself, privacy is maximized when we all have exactly the same amount. Right? If we all pay exactly 0.1 Bitcoin to our addresses, then there is no subset sum analysis possible of which of these outputs belong to which user, because all outputs are essentially the same, including the amount, just their public keys or addresses is different. And so therefore, all initial CoinJoin implementations created outputs of the exact same value for all users. And here, Chaumian and Ecash came in as a perfect replacement, because in the traditional Chaumian or Schnorr blind signature scheme, there are the anonymity set of the user depends on the amount of the token. And so a 0.1 Bitcoin token and a 0.5 Bitcoin token are fundamentally different looking to the mint, because the signature on these tokens is created from a different private key. And therefore, the value of the token is defined by the mint. The mint says, these are my keys, and this is the values that it represents. Right? And so the mint enforces all the users to, you have to pick this amount, because you will only get an anonymous Ecash token worth that amount to be registered on the output side. And that is ultimately for the blockchain privacy perfect, that every user gets the same denomination at least once, and that means there's a large number of users sitting in the exact same anonymity set pool. However, in reality of implementing the system, it turns out to be very inefficient, because what if a user comes in with 100 Bitcoin and the mint only gives him a 0.1 Bitcoin token? Right? Then he needs to get 99.9 Bitcoin change back, right? Where the 0.1 Bitcoin is anonymous, because there's hundreds of other users with the same amount, but there's only one user with 99.9 on the output side, and there's only one input with 100 Bitcoin on the input side, so it's very obvious which big change output in an arbitrary value belongs to the initial input owner. And so this user would have to make, well, at least 1,000 transactions, right, to break down his 100 into 99.9, 99.8, and so on. That's a lot of transactions, a lot of block space, quite expensive and slow. So our next idea was to add a second denomination and a third denomination to the standard denominations that the mint prescribes. So whereas Wasabi 1.0 shipped with only 0.1 Bitcoin Ecash credentials, so only one private key for the mint, and only one standard denomination output batch or pool in the transaction, Wasabi 1.1 had a multiple private keys for the mint that represented 0.1, 0.2, 0.4, 0.8, so the powers of 2 series. And still, however, the mint demanded that every input, or like every owner, every input user, let's say, participates always in the 0.1 pool. And only if you have money left over, you go to the 0.2 pool and such. So this had still some downsides in this version, that the mint needed to know all of the inputs of a single user, right? Because what happens if a user has only 0.05 Bitcoin, but that's less than the minimum denomination, so he cannot get privacy for this coin if he would just register it by himself. Right? He needs to register 2 or more coins so that the sum of inputs is larger than the minimum denomination. And that gets proposed in the first API call. So in this system, the mint knows that all of these inputs belong to the same user, and that this user got Ecash worth 0.1, 0.2, 0.4 as an example, and that the user got a change back of 98 point something. And so this means that ultimately still a lot of information is revealed from the client to the mint. However, crucially, that link between the input group and the standard denomination outputs, that was where we actually achieved full privacy thanks to the Ecash transfers. But because of the limit of the mint has to define the amount of the tokens, there was no efficient amount decomposition possible. Plus, even more, the mint demanded how to decompose. You have to decompose from the bottom up, right? If you have to get a 0.1, and you cannot get a 0.2 only without that 0.1. So still quite a lot of restrictions on how the end user software can use this protocol and express user preferences in actionable reality, which again costs time and money. So our latest innovation was in Wasabi 2.0, I think published 22. And that is basically a anonymous amount Ecash scheme, where the value of the token is no longer defined by the mint private key, but rather the mint only, for all intents and purposes, has one private key, and the user encrypts the amount of of satoshis or value in this token, encrypts it locally in such a way that the mint can still check that the sum of the inputs is equal to the sum of the outputs. So this uses homomorphic value encryption, which is basically just means encrypting a number so that you can still do math on the ciphertext. That makes sense. And when you then decrypt this computed ciphertext, you get actually real proper values at the end. Many cool applications for this, but fundamentally this was, I think, first invented by Blockstream researchers for confidential transactions, which is now deployed on Liquid and on Monero, for example, and Zcash. And it basically means that while in a traditional Bitcoin transaction, we see that there's 5 outputs that all sum up to, I don't know, 1 Bitcoin, and there's 2 outputs that all sum up to 0.99 Bitcoin. Right? The 0.01 is the mining fee, and the verifier sums up the clear text numbers, checking that they're equal. So very simple math that a computer can do. But what's also possible is that the person who creates a transaction, let's go back to the Ecash use case, the person who creates a transaction always spends 2 inputs, 2 Ecash tokens on the input side, and he always generates 2 outputs in the Ecash transaction. And so the 2 coins that he has, let's say a 2 Bitcoin token and a 3 Bitcoin token on the input side, the 2 and 3 is encrypted into ciphertext. Right? On the output side, he generates the 2 new Ecash tokens that he would like to receive from the mint, where again, he adds, let's say, 4 and 1. These numbers are also encrypted. And now the mint verifies that the encrypted sum of the 2 inputs is equal to the sum of the 2 outputs. Therefore verifying that there is no inflation, meaning nobody just spent a 1 Bitcoin Ecash token and gets a 10 Bitcoin Ecash token, which is ultimately what the mint wants to avoid. But doing in such a way that the mint does not know what the value of this token is. And so, for example, if you start out with a 5 Bitcoin token and you want to break it down into smaller, the mint also gives you for free a 0 Bitcoin Ecash token. So a token worth 0. And so what you can do is you take the 5 Bitcoin token and the 0 Bitcoin token, and on the output side you have 2 and 3, for example. So this way you can split, even if you only have 1 valuable token, you can still split it in a transaction that looks the same. So in this Wasabi Ecash system, each transaction looks the same because it always has 2 inputs, always has 2 outputs. There are no spending conditions like public keys, script blocks, etc. Could be added, but not in this current implementation. And the amounts are all encrypted. And therefore, regardless how much sats you transact, in fact, you can even transact 0 sats by spending only 0 value credentials and creating 0 value credentials. So you're not even a true user of the system because you don't have any valuable tokens, but still you provide cover traffic so that even the guy with 1,000 Bitcoin on input and output side looks indistinguishable from some basic free spam attack. And that means that we have a much larger anonymity set for the Ecash transactions, and that allows us in the coin join model to build transactions of arbitrary values. So whereas before we had a minimum amount of 0.1, we could now drastically reduce this to 5,000 sats, could be even lower, so that basically any single input, even if you're rather poor and only have 15,000 sats as an example, you can still register just this one input, and you don't have to tell anyone else which other inputs you have, because it is now possible to register arbitrary value inputs and receive an arbitrary value Ecash token, but it's still perfectly private. In the traditional unblinded amount Ecash schemes, users always have to worry about coin selection and yeah, which denominations to generate. And it basically means that at the end, your Ecash wallet has hundreds of tokens worth of different denominations. With a Wasabi or blinded amount Ecash scheme, users can have just a single Ecash token. And that holds the arbitrary value, the exact value that they have right now in their wallet, but it still is a perfect anonymity set. So that means we have much more flexibility for the user in which denominations does he generate, which leads to much more efficient amount decomposition, which is extremely important for us in the blockchain context, because for every additional output that you register, you have to pay block space fee, not just to generate that output, but to spend the coin later on the input side. And that just means you need to have a very efficient way to decompose your arbitrary input value to a small set of like standard denomination outputs. And yeah, Wabi Sabi or anonymous amount Ecash credentials do that. And again, the cool thing is that this tech, which is a rather big improvement in Ecash tech, was really built not for the use case of money warehousing, but for the use case of anonymous API access right tokens, and then specialized for the constraints that this application layer gave us, right? Whenever you touch the Bitcoin blockchain, it gets really expensive. So efficiency is key, and that's why we designed a system where we optimized for efficiency of the result. But there are many other use cases where you can customize and tweak the Ecash scheme to a large extent to fit your purpose and your approach, and that's quite valuable. So Ecash is not just about money warehousing, that's for sure a very cool part of it, but it really allows us to get rid of the account abstraction for services provided. A lot of services can now be provided without the provider having a record of accounts where he can cluster all user action and then discriminate. Right? So anonymity is always hard because your attacker can easily Sybil attack you, and you don't know that the next user connecting is still the same old attacker. So there are a lot of issues with creating anonymous systems that are still reliable and secure and scalable. However, anonymous tech also provides us extremely powerful niche applications, like, for example, this anonymous API access right management, that is good enough to actually make that system of accounts completely obsolete. And so I'm sure that there's a bunch of further applications that can benefit from Ecash in novel and unique applications that you will come up with at the hackathon later today. So thank you very much. And if you have any questions, please shoot ahead. Do we have a mic runner?
Questions?
If I'm understanding correctly, it sounds like you need to register multiple inputs and outputs. Because if you register a single one with arbitrary values, it would be trivial to docs. It would be trivial to link the input and the output. Is that correct?
Okay, very good point. I didn't mention this. So let's say you have a 0.12345 input, and you register this, and you get a Ecash token worth 0.12344 minus fees. And now this Ecash token, you could register it directly for the output of the exact amount. But then you're correct, right? You have the problem of amount linkability. But the cool thing again is Ecash is basically instantly and free transactable. So what you can do is spend the Ecash to yourself. And so you register your 0.1234 and let's say another 0.2, then you make an Ecash transaction with these two on the input side and whatever you want on the output side. And you might have to do 3 or 4 Ecash transactions to get all of the outputs of the exact amount that you want, but it doesn't matter to make Ecash transactions. They're so ridiculously fast that nobody notices it. So the system is designed for the user making self-spends of the Ecash token to not just increase the anonymity set of having more transactions, but also especially to help the user adjust the amount. And then one extension of this is that it's not necessary that users make these self transfers to yourself, right? It's in fact indistinguishable if I copy that Ecash token, give it to you, and you register it on the output side. The mint does not know that this was not a self transfer, and in fact the Ecash token changed hands, right? So he does not have any inputs registered on this Bitcoin transaction, but instead he gives me pizza, and I give him an access right token to a CoinJoin, where he has the assurance that he can put this amount of money on the output side of the transaction. And he could also add a couple of his own inputs, right, or add more payments on the output side of this CoinJoin, or even hand the Ecash token to the third guy. And so because the Ecash token is transferable, this is almost like a second layer payment technology, second layer in big quotes, because it's anything but trustless. Because first of all, the coordinator could just go offline and stop coordinating this transaction. Or one of the users does not sign for one of the inputs this transaction, and then it's invalid. So we have to do it all over again. Or even if every user signs the transaction, we chose a low fee rate, and now fee rates are much higher, and it won't get confirmed anytime soon. And then someone could still double spend the transaction, even after it was successfully broadcasted, but still unconfirmed. So the failure rate of a CoinJoin is quite high, which means that relying on the coordination mechanism for payments is rather unstable, but the privacy aspects of it are unheard of. Because this way, you can send someone else on-chain Bitcoin without the sender ever knowing the address of the receiver. You send someone money, but you have no idea where he got it, or if he even got it, or if he passed it on to the next guy. Right? So it's absolutely insane privacy levels for transferring these API access rights in the CoinJoin context.
Money warehousing inside of a CoinJoin.
Just to follow up on that, would it make sense then to have CoinJoins sessions that are deliberately delayed? Like instead of trying to do it every hour, you say, well, we're going to do it next Friday. And, keep in mind, like you said, the CoinJoin might get rugged. But if you want to do this offline transfer, you've got a week to do it instead of just a few minutes.
Absolutely. The timeouts are configurable by the coordinator. And so you want to have longer timeouts if you have less users. And if you have a lot of users, you can afford shorter timeouts because you will be building big transactions even after shorter time. But there's other reasons why you would want to adjust this timeout. One might be multi-sig, right? You have multi-jurisdictional, multi-sig cold storage, and it simply takes you a week to travel to all of the locations to get your private keys to sign, the music taproot signature for this. So in this case, there could be some much more manual CoinJoins that do take weeks for these edge cases where we want to spend heavily secured and with complex spending access rights coins still privately.
Sounds like a bad idea to have like you doing all these business class flights to multiple continents to sign one CoinJoin and then it fails and you got to do it again.
Yeah. And you have to do it two times in a round, because first you need to prove that you can spend the input without actually spending it, just by signing in. And then later you actually have to sign the transaction.
We can get one of these unlimited flight tickets.
Yes. And in fact, in Wasabi, you can actually buy flight tickets with the buy anything button from ShopInbit. So vertical integration.
Did Wasabi ever support keeping those tokens until another round so that your input and your output are not even in the same transaction, but like cross time?
Yeah, this is an interesting idea to And there are ways of doing this, but the problem is, again, fundamentally that the Ecash token in Wasabi is not a money substitute, right? So it's not as good as Sats. It's as good as access to the API, right? Which doesn't mean that you get Sats at the end. And so therefore, like stringing it across two transactions doesn't make sense because two transactions are fundamentally two different API sets of API calls, right?
You would have to bridge the leftover money into the next round, and then you make them.
So what you can do, not by even changing the Wabi-Sabi protocol, but simply plugging in an existing Cashew or Fedimint, is you simply deposit to the Fedimint. Let's use Fedimint because it has on-chain addresses depositable available right now. So you generate your Fedimint deposit address, you put that on the output side of a coin join with the amount that you want to deposit, and now you get Ecash tokens from the Fedimint that is actually long living, not in a single transaction coordination, but it is as good as Sats. And now you can use that to spend it wherever. And then if Fedimint would also have a coin join, or like, well, the withdrawal, the peg out of a Fedimint is a bit more tricky. And usually you would use the gateways anyway. So what you can do is you simply give your Ecash tokens to a swap provider, and that swap provider from his own single sig wallet makes a payment in a coin join back, so that he puts your address on the output side of the transaction, or in fact that he registers the inputs, gets you the Wabi-Sabi credential, and the user registers his output address, so that the Mint gateway doesn't even know to which address the peg out happens. So this is all possible to combine deposits and withdrawals into other higher layer technologies. This works the same with Lightning. You could already for a long time open a Lightning channel on the output side of a coin join. And now since closing V2, we can also close a Lightning channel cooperatively inside coin join coordination. At least in theory. I don't think anyone implemented it yet. But so it is possible to even do splicing inside a coin join, to close a Lightning channel on the input side and open another Lightning channel to the same user with a larger or smaller amount. And that is all possible without anyone having direct linkage of the inputs and outputs. But yeah, it always seems tempting to make the Wabi-Sabi credential behave more like a money substitute, but it's just fundamentally not. It's a very, even this payment mechanism that I described, where people can share or send the Wabi-Sabi Ecash to other people for registering their outputs, even this is just extremely fragile, right? Because like it's not uncommon that the first attempt to a coin join fails 50% of the time, right? So if every time you make a payment, like it behaves the same way as on-chain, that the merchant needs to wait for the on-chain confirmation. Right? So when you give the merchant your Wabi-Sabi Ecash, the merchant doesn't instantly give you the pizza, right? But he registers it out his output. He asks you to sign the transaction. We wait for it to be signed. We wait for it to be broadcasted and confirmed, and only then does the merchant give you the pizza. So it's not instant. It's much less unreliable than traditional blockchain transactions. But again, privacy is just breathtaking. Yeah.
Unless we have any further questions, or one more question, but on the topic of pizza, included in your ticket, we have a very fine lunch served just around the corner, just through the curtain. Momentarily, talks this afternoon will be resuming at 12:45, both here in the planarium and workshops on one floor below on level 3, also from 12:45. But the final question.
So I know you're going to great pains to emphasize that they're not money and they're not even money substitutes. I'm curious though if you think there's any case for ascribing any non-zero value such that the money-like properties can then be exploited in interesting ways.
So you mean that there's likely to be a price emergent for these tokens if we have a free market where people can
I
sell
wonder
them?
if you think that's at all possible, yeah.
I mean, okay, so like let's walk through this. I register an input, I get the Wabi-Sabi Ecash credential. Now I give you that Ecash credential, would you give me money right now for the Ecash credential, right? Would you give me actual sats? Because like, let's assume you give me sats even at a 50% discount. So like the token is worth 1 Bitcoin, but worth 1 Bitcoin, right? It's worth to register an output worth 1 Bitcoin. And you give me 0.5 sats in Lightning instant settlement. Now, what if I just walk away? Right? You have the output, you have the right to register an output in a transaction where I have an input that I will never sign because I just got your sats for real, right? And you accepted the Ecash token. So I walk away, and this round, and again, the Ecash is locked to the round that we're currently creating. And if we remove an input, it's a different round, right? So therefore, if you are happy to give me money right after I give you the Ecash and I walk away, there's no remorse for you. So then I guess that discount would be the risk premium of how likely it is that this person would walk away, right? But also, how likely is it that other people walk away? Again, like 50%, nowadays maybe 80% or something of transactions succeed, but that's still not good enough. So the discount would be quite huge. And so, plus, there's massive inflation in these tokens, right? Coordinators can start new rounds all the time, so different currencies, so to say, get created all the time, and then yeah, you don't know how many other tokens get generated because people register inputs staggeredly, so you wouldn't know the total supply of these tokens from the beginning. So pricing them is very tricky. Yeah. Any more questions? Great. Have a good lunch. Thank you.
Thanks, Max.